In this example, we have two cars in a head-on collision. One car is traveling with a velocity of 19.3 meters per second. The other is traveling with a velocity of negative 22.1 meters per second. When they collide, they stick together and move as one. I'm going to summarize the things we know. We know the velocity of each car and the mass of each car. And the question is, what's the velocity of the two cars once they lock together and move as one? Now, the key to solving this problem is to realize that the momentum before the collision has to equal the momentum after the collision. So the mass of car 1 times the velocity of car 1 plus the mass of car 2 times the velocity of car 2 before the collision has to equal the momentum after the collision. Well, what's the momentum after the collision? The two cars are moving as one, so they really just make one object. The mass of that one object is the mass of car 1 plus the mass of car 2. To get the momentum then, we just multiply that total mass by the velocity of the two-car system, which is what we're trying to solve. So the equation you see there is the mathematical representation of momentum conservation for this particular situation. Now let's fill in the numbers we know. Mass of car 1 is 675 kilograms. Velocity of car 1 before the collision is 19.3 meters per second. The mass of car 2 is 895 kilograms, and its velocity before the collision is negative 22.1 meters per second. Now I'm going to run out of room on the whiteboard here, so I'm going to start the right side of the equation right underneath. This has to equal the mass of car 1, 675 kilograms, plus the mass of car 2, 895 kilograms, times the velocity of the two-car system, which we don't know. When we take care of all the numbers we can take care of, this big equation reduces to negative 6.75 times 10 to the 3 kilogram meters per second, equals 1570 kilograms times the velocity of the two-car system. Dividing by 1570 kilograms to solve for the velocity of the two-car system, we see that kilograms cancel, and we find that the velocity of the two-car system is negative 4.30 meters per second. That negative, of course, tells you the direction. The two-car system is going to be moving in the same direction that car 2 was moving before the collision.